Hey guys, I wanted to create a screencast to go over some of the additional features that we're trying to add to our ship shooter game. So this is where we left off. We have our basic ship shooter going around and we have the ability to shoot. We don't have collision detection yet, which I'm going to cover in this video. And also, as you can see in my environment, I don't have any images for either our ship or our enemies. So let's go ahead and try to solve that. I'm going to go ahead and first do the images. So there's a game that I used to play when I was a kid on Nintendo called 1942, and it was a cool similar type of game. So I'm going to go ahead and take a look in Google Images for 1942. I don't know if any of you guys have ever played this game, but it's a classic game for the NES system, Nintendo system. And let's just search for plane. Here we go. I'm gonna find an image that I like here. Now I'm looking specifically for an image that is a PNG. So if I go ahead and right click and go save as, I want it to be a PNG. So that looks good. So I'm gonna call this our ship.png, and that's in my downloads folder. I'm gonna go ahead and remember that for later. And let's go ahead and grab a bad guy. So maybe the bad guy is maybe this guy. Or is that too similar? Maybe. Let's go back and let's see if there's anything else here that, yeah, I guess we could do that guy. So we'll go, no. Yeah, I guess we can use that other guy, but I'm looking for, oh yeah, here we go. I think this is more like the bad guys. So I'm gonna go ahead and save this. This is a PNG, yes. So we'll say bad guy.png. So we got both the ship and the bad guy. Now what I'm going to do here is we're going to get into our editor. And the first thing we're going to want to do is upload those images to our images directory. And now that we downloaded them, we can actually have a ship in here. I'm going to go ahead and delete this one. And I'm going to right click here and go to upload. Now I'm going to go ahead and just click here to show the uploader, and I'm going to go ahead and select, I have a couple of ships here in the downloads directory, the ship, and now I'm going to do the same thing with the bad guy. Awesome. So now we have both the ship and the bad guy in our images directory, and now we can go ahead and use them. Now remember from our DVD logo project, I'm going to go ahead and open that. We need to use this preload function. So I'm going to go ahead and copy this preload function and dive into our ship shooter and put that function right above the setup function. Now, this used an image variable, but we're going to need two image variables now because we're going to use the ship and the enemy. So I'm going to go ahead and declare two global variables. Let ship, I'll call it ship sprite. Typically when we talk about a series of images in a video game, we usually call them a sprite. In this case, it's really only one image, but once we get into animations, you'll see how the word sprite comes into play. So I'm going to say ship sprite, and we're not going to actually declare it here. And then I'm going to say let enemy sprite, just like that. So now we have two global variables. Remember, those variables are like buckets where we can store information in, or think of it like a suitcase, right? So now we have these two variables. Now instead of using image here, I'm going to call this one ship sprite, and instead of the DVD logo, we're going to go ahead and grab the ship.png. Right? Now I'm going to take this exact line, I'm going to copy this, and I'm going to paste it. Now I'm going a little bit quicker than I normally would in class. If I am going too quick, please pause the video and take a look at where we're at. And I'm going to go ahead and say enemy sprite, and this is going to be, what do we call this bad boy? We called it bad guy.png. So we'll go ahead and type bad guy.png. Awesome. So now we have two variables, and within those variables, we have the image information that we got back from the load image calls. We're looking pretty solid now, right? Now the only thing we need to do in order to render our images is go down to our ship and our enemy, and where we draw our triangle, instead of drawing the triangle, I'm going to comment this out, we're going to use the P5JS image call, and we're going to say image, And then the first parameter is going to be the image data that we need to pass in, which in this case is going to be the ship sprite. Then we're going to have to give it a location. So it's going to be this.x and this.y and this.y. And then we need to give it a size. Let's give it a square size of, say, 200 by 200. We'll see how that looks. That may not actually look very good. But now we can also take this line, we'll copy it, and we're going to do the same exact thing in the enemy. So we're going to go down here to the enemy, and instead of making a rectangle, I'm going to comment this out, and we're going to paste this in, and then we're going to do the same exact thing, but instead of using the ship sprite, we're going to use the enemy sprite. So now hopefully you can see how we can take our code from our functional prototype and convert it into a more polished look and feel by just simply flipping out the simple geometry that we're rendering to using image data. So now we're just rendering some image data. So let's go ahead and run this and see how bad it looks. Okay, so not that bad. Whoa, these guys are looking pretty big. So we've got these big guys coming out, and our good guy is looking pretty big as well. So why don't we go ahead and scale these bad boys down so that we can make it look a little better. So let's make the enemies, instead of 200 by 200, let's really make them smaller. I think they were really big. So we'll make them 50 by 50, and we'll go back up to the ship, where our ship's draw method. Where are we? Ship's draw method. Where is the draw method? There it is. Now we're going to go ahead and make this. Let's make this maybe 75 by 75. We'll make the actual good guy a little bit bigger than the bad guys. Let's go ahead and refresh that. That looks a lot better. Look at that. Nice. Beautiful. That's looking really good. So now, one little caveat here is the laser is coming out of the top left corner of our ship. We can do a couple things. We can make the lasers come out maybe twice from the wings, or we can make it come out from the center of the ship. Why don't we make it come out from the center of the ship? Really simple to do this. So if we go back to our code and we go to the fire method, which is where we actually, no, it's not the fire method. The fire method is only, we only add a bullet to the bullets array. We want to go to the, still within the draw method of the ship. The draw method of the ship is where we call the draw method of the bullet. So that kind of leads us into the draw method of the bullet. So let's go down to the draw method of the bullet. And here we go. So now we draw a line, this.x, this.y, and this.x, this.y. Now, actually, I don't think this is where we want to do this either. I think we want to do this. Yeah, I think we were right. Our first assumption was correct. When we create the bullet, right? So we're creating the bullet, and the starting position of the bullet is the ship's X and Y coordinate. What we want to do is we just want to move over that X and Y coordinate slightly, or really just the X coordinate, right? So I'm going to move this over by saying X plus, because we're going to go to the right of the screen, plus say, let's say 50. And let's see how that changed. We're going to refresh it. Whoa! Okay, we went a little too far. So maybe 50 is too far. Let's say 40. Okay, almost. Maybe 37. Now we're honing in. Okay, that looks pretty good. All right. Excellent. So now we have images for our enemies and images for our ship. Looking good. Now, where we left off in class last week was trying to get collision detection working. So I'm going to go ahead and tag the video portion right now so you can skip to this if you chose to. And we need to get collision detection working. So what we did was, if we go back to our code, we learned about nested loops. So what we did here is we looped through, and we're within the actual update method of our ship, right? So every time the ship updates, what the ship is going to do is going to look at each one of the bullets that ship fired, and then look at all the enemies that are on the map for each one of those bullets. And then check whether or not the enemy that we're looking at and the bullet that we're looking at are within the vicinity of each other. So what we're doing is literally developing a hitbox for each bullet and each enemy. Okay, so we're developing basically a hitbox here, and we're doing it by using a nested for loop. So you can see here, a nested for loop basically means a loop inside of a loop, right? A loop inside of a loop. Now, we weren't able to get this to work in class, and there's a couple of reasons for this. And I want to show you how we can go through a small process of debugging this. Now, what we did was we said for each bullet, we want to look at each enemy. Now, when we're looking at each enemy, we're going to take the difference between the x coordinates of the enemy and the bullet and the difference between the y coordinates of the enemy and the bullet and see if they're less than or equal to 5. Now, there's a couple of problems with this approach. Basically, the logic is correct in terms of how we're approaching the problem, right? We need to take the difference between these coordinates to calculate some distance and then see if that distance is below some threshold. If it's below that threshold, then we can rightfully assume that we have a hit on our enemy and we're good to go. But the problem here is that our enemies are moving down the screen in a negative Y position, and our bullets are moving up the screen. The Y position is always negative. So when we do this subtraction, it's never really resolving properly because of the fact that we are dealing with negative and sometimes positive numbers. So it's not jiving. A technique that we can use here is use absolute values. Now, I don't know if any of you have ever learned absolute values. I believe you probably did in high school. An absolute value is basically just a positive number, right? If we have a -5 and we take the absolute value of -5, it's 5. If we take the absolute value of +5, it's 5, right? It's the absolute number from 0, no matter what direction you're moving in. So if you're moving in the -100 position, the absolute value from 0 is 100, right? And same thing goes if you're moving in the positive direction. So this way we can kind of take our numbers and convert them into a format that makes more sense to actually see what the difference is. And one way you could go about debugging this is by taking the difference here, right? This dot bullet sub I minus enemy sub j dot x, and putting these into a variable. So I'm going to copy that, and I'm going to declare two new variables here. I'm going to say let we'll say diff x equals this subtraction, and let diff y equals this subtraction. So we're just basically storing this data in, oh, and that's a problem too. It should be enemy sub j. So that's actually a bug. That's not right. So we'll take that out. Now what we can do is we can console.log diff x and console.log diff y. Now this is going to give us just a stream of numbers that we could just take a glance at to see if they're making sense at all. So I'm going to go back here. I'm going to hit F12 or right click and inspect and go to console to open up our console. I'll just go ahead and click this to clear us out and then hit refresh. Now, there's no bullets on the screen, so we're not going to see anything. But once we put a bullet on the screen, boom, now we start to see this. And you can see here that we have a lot of negative numbers and a lot of pretty large positive numbers, right? So the X position is most likely the positive ones, and the Y position are really, really negative. Look how they're growing. They're getting bigger and bigger in terms of the negative values, right? So they're always negative. So if we're saying, hey, if you're greater than or less than 5, or equal to 5, it's never really going to get there necessarily, right? So in this case, actually, we take the difference. They're always going to be less than, but it's never going to be less than 5 in the X position. So what we're doing is we're testing two things, but we're expecting them to be less than 5. One will never be less than 5. In the case the X position, it's growing, and the Y position is decreasing. So they're kind of diverging in direction. One is getting bigger and bigger in the positive direction. One's getting bigger and bigger in the negative direction. So that's a problem because this conditional will never resolve to be true, and we'll never get a hit. That's not going to work. There's a simple way around this though. using absolute numbers. So instead of just taking the difference here, we can use a built-in object that's in JavaScript, the math object. And we can say math, whoops. We can say math dot ABS for absolute value, open parentheses, then put our subtraction right in there. So we're going to do the same thing here. I'm going to say math dot ABS, and then we'll take the subtraction. Now we can be assured that these will always be positive numbers. So I took that console.log out, but if we put that console.log back in real quick, all right, I'm going to put that in, and then we'll put this in. And now we have some notes there. We want to go here, and we'll go ahead and refresh that. We'll put a bullet on the screen. Now you can see these numbers are always positive. Look at that. So now we know that we can test for these values consistently. So now what do? Now that we have these values in two variables we can test, we can now simplify this conditional by taking this piece out and then saying if the diff x is less than 5, or if the diff y, or I'm sorry, if the diff x is less than or equal to 5 and the diff y is less than or equal to 5. That's going to create this box, right? We're drawing this box in both the x and the y coordinate systems. Now this is pretty tight, so maybe we want to make this a little bit bigger. Maybe we'll say less than or equal to 15. So our hitbox is slightly bigger. And you know, you can even correlate this to another variable if you wanted to, and maybe correlate it to like a difficulty for your game. If you're in hard mode, you would make this number smaller, and if you're easy mode, you would make this number larger, right? Because that's the size of your hitbox. So now if we go here and we refresh this, we are console.logging when we hit. So I'm going to shoot, and then boom, we hit that guy. Boom, we hit that guy. Notice how we're getting hits, right? Oh, we hit him. Boom, we hit him, right? See how that number is getting bigger and bigger here? So we have collision detection working, but the enemies aren't doing anything when you actually hit them. They're still coming at you. So that's a problem too, right? Why don't we do something with them? Now we can get super creative here, right? And we can go into how to draw maybe a series of images that simulate an explosion. I'd love to get into that. Maybe in another future video or future lesson in the next level class, we can do that. But for now, what we're going to do is we're just going to introduce this idea of an enemy being alive or an enemy being dead, right? And when it's dead, it will not render to the screen. Right? Maybe we want to even go a step further and say when it's dead, maybe remove that enemy from the array. And maybe we'll do that. So let's go ahead, go back here. Now, in order for us to determine whether or not an enemy is dead or alive, we need to actually give the enemy that behavior, right? We don't have the behavior of dead and alive in our enemy. So that is a problem. We need to figure that out. So we have to go into our enemy and work on this bad boy a little bit. So we're going to need a new property, right? And what is a property? A property is just a variable that lives inside of our class. So let's go ahead and do that. I'm going to say this inside of our constructor, this.alive equals, and I'm going to assume that every enemy starts its life alive. I'm going to say this.alive equals true. So we're assuming that it's alive. Now what we're going to do is, within the draw method, I only want to draw the enemy, or have the enemy draw itself if it is in fact alive. So what I'm going to do is I'm going to say right before this image function call, I'm going to say if alive, oh, I'm sorry, if this.alive, you can't forget that right? Then we'll wrap this image in a new code block here. So now the image will only be called if the enemy is alive. Aha, now what can we do? Now we know when we hit an enemy, because we have this cool little algorithm here that's doing nested loops and calculating a hitbox. And we know here we hit an enemy We also know the exact enemy we hit, right? Enemy sub j is the one we hit. So now if we say enemy sub j dot alive, because now we can access that property, equals false. Now in larger environments, you would not necessarily directly access the property. You would have maybe a method that you would call that would change that property. But for all intents and purposes for this lesson, we can go ahead and just change that right away. So we're going to say this.alive equals false. Now watch what's going to happen. Boom! Once we hit an enemy, it goes away. Now we may want to change that hitbox a little bit. I'm noticing I'm getting in there a little, maybe make it a little bit bigger. But the enemy will go away. Now it's still on the array. I won't go necessarily into how to take it off the array. It's technically still rendering, but it's just not drawing the image. But that's cool. So we now have this hitbox working. Awesome. Now, bonus. I'm gonna tag the video here too. Next bonus here. Let's gamify this a little bit and let's create a little score in our game. Okay, so let's see. If we wanted to create a score in our game, every time we hit an enemy, we wanted to increase a score. So this takes it back to the basics, right? So really the score is just going to be a single variable, right? Think about this. Is it going to be a global variable, or is it going to be a variable that's local, a property to any one of the classes that we've defined? The ship, the enemy, or the bullet. It's going to be a global variable, right? Because this is going to be about the whole game. So we're going to make a global variable, and let's say, we'll say let score. Okay? And now when we start the game, we'll go in our setup, and we start the game, we're going to make the score 0. Now, when we hit an enemy, we want to increase that score by 1. So let's see how that works. Super simple. So right here, where we actually hit the enemy and calculate a hit, we're just going to say score plus plus. Now the score increased. Boom. But one thing we're not doing is we're not displaying it, right? We could do this. We could say console.log score, and now we'll see the score written to the log, right? So I refresh this. I'm gonna shoot, and boom. So you notice here, because we're testing it on multiple frames, you're getting multiple points because you're technically hitting the bullet is traveling through that hitbox multiple times. So you can see that we are getting more points than just 1 when we hit the enemy. That's fine for now. We don't have to, we don't have to get too crazy with that. Maybe there's ways we could figure that out. But for now, we are getting a score, right? But we're not showing the user that. So there's a helpful function in P5.js to be able to just output text. And all it is text. So it's a text function. So all we have to do is call the text function, and the parameters on the text function are the string we want to display, in this case the score, and the x and y coordinate of where we're going to place this text. So let's go ahead, go back here, and in our main draw function, this is not going to be tied to any given object that we've created. The first thing we're going to do is let's display our score. So we're going to go ahead and say text, and first thing is we're going to tell the user that this is the score, right? So we're going to do score here, and maybe we'll make it at I don't know, 10, 10. Let's see how that looks. Now let's just refresh this. Okay, so it's up there. Maybe move it down a little bit more in the Y position. So maybe 10, -10. Oh, I'm sorry. Maybe we got to go up. Maybe it's +10 because we're moving. There we go. So maybe not 50, maybe 30. And I think there's functions too where we can change the font size and stuff, but we'll look at that in a minute. So 10, 30 is fine. So the X and Y, and now we're going to copy this and we'll keep it on the same X. I'm sorry, on the same Y, but we'll move over the X. Say this was 5, 6, 7 characters. So we'll say maybe 20. Just give it a little space. And instead of score, we're gonna output the variable score. So now, oh, okay, that's not enough. We need to go more than that. So we're gonna go, say, 70. Okay. All right, that's a little too much. Let's move it in a little bit more, maybe 50. And okay, that's better. So now, as we shoot this, look at that. Our score's going up. Boom. Boom. And now we just gamified the whole thing. So let's see how high of a score we can get. Oh, I missed that guy. Ah, this hitbox in this game. I don't know. Just keep it dangerous out there. So cool. Now we have a score. You notice the stroke, though, is becoming red once we shoot. So we're doing this before... We don't actually have a no stroke in here. So why don't we do that? Let's put a no stroke in here so that it doesn't do that. And, oh, did I... No stoke, no stroke. Spelt that wrong. Okay. Now, there we go. Cool. Now, I'm not really digging that font size. Is there text size? So we have a text size function. So let's go ahead and grab that. Let's say text size is, let's not do width divided by 3. Let's do, I don't know, 20. Let's see what that looks like. Okay, that looks better, but now we just need to move over this now. Maybe 70 works. Maybe a little bit more. Just a little bit more. There we go. 75. All right, that looks good. Nice. Nice. Now we got a score. So what I'm going to do is I'm going to share this with you guys. I'm not going to post this to GitHub just yet. I will post it after this week. But what I want to give you guys an opportunity to do this. This will be counted as extra credit if you do go through this process and get the game into this state where you have a score and images for the enemy. Super bonus if you can get the enemies to shoot. If you can get the enemies to shoot, that would be a huge bonus. I know I've worked with at least one of you to do that, and maybe you guys can work together a little bit to figure that out. That would be awesome. But I will stop it here. So we do have images loading, we have collision detection, and we do have a score system. All right, guys, have fun. I'll see you next week. Thanks.